Download this code from codegive.com, link in the description below. Sure. Support vector machines, SVMs, are a powerful supervised learning algorithm used for classification and regression tasks. They are particularly effective in high-dimensional spaces and are well suited for datasets where the number of dimensions exceeds the number of samples. What is an SVM? At its core, an SVM tries to find the best hyperplane that separates data points of different classes in the feature space. The best hyperplane is defined as the one that maximizes the margin between the closest points of each class, known as the support vectors. Key concepts. 1. Hyperplane, a decision boundary that separates different classes. In 2 dimensions, it is a line, in 3 dimensions, it is a plane, and in higher dimensions, it is a hyperplane. 2. Support vectors, data points that are closest to the hyperplane. These points are critical as they influence the position and orientation of the hyperplane. 3. Margin, the distance between the hyperplane and the nearest data point from either class. SVMs aim to maximize this margin. 4. Kernel trick, SVMs can use a kernel function to transform the input space into a higher dimensional space, enabling the algorithm to find nonlinear boundaries. Common kernels include linear, polynomial, and radial basis function, RBF. When to use SVMs. When the number of features is high relative to the number of samples. When the dataset is not too large, as SVMs can be computationally intensive. When you need a model that is effective in high-dimensional spaces. Example, SVM for classification with Python. Now, let's go through a simple example of using SVM for classification using the popular scikit-learn library in Python. We will use the iris dataset, a classic dataset for machine learning. Step 1. Install required libraries. Make sure you have scikit-learn, NumPy, and matplotlib installed. You can install these using pip if you haven't already. Step 2. Import libraries. Step 3. Load the dataset. Step 4. Split the dataset. Step 5. Create and train the SVM model. Step 6. Make predictions. Step 7. Evaluate the model. Step 8. Visualize the decision boundary. Conclusion. In this tutorial, we've covered the basics of support vector machines, how they work, and how to implement them using Python's scikit-learn library. SVMs are a great tool for classification problems, especially when dealing with high-dimensional data. Feel free to experiment with different kernels and parameters to see how they affect the model's performance.